Okay, so hexagonal architecture. So it's simple as a cake, right? I mean, we have the domain on the inside. It is hidden behind this hexagon. I mean, it's not necessarily a hexagon in this picture, but you know, you do what you do. And it's strongly isolated from the outside world and all of its concerns. That's what it says on the tin can. That's the marketing spiel. But it still has to somehow, you know, cooperate with the rest of the world, right? So on one hand, it needs to be consumed by the outside world, and maybe it also needs to consume some aspects of the outside world, right? So for example, and to do that, we have the ports and the adapters. So for example, we might want to expose a RESTful API, for example, for our service, and this is for primary. This is what primary or driving adapters are for. So this is just one of the examples. There are many more. So we can consume some events. We can be consumed by CLI or whatever else. Plenty options. On the other hand, our application also needs to consume some of the, right? So, for example, database. So this is what secondary or driven ports and adapters are for. So this is one of the examples. Again, there's more. So we can emit some or publish some messages, right? We can, if we were consumed by CLI before, maybe we can consume a file system. Maybe we can consume some other processes through a CLI. There's also plenty of options, right? Yeah, and ports and adapters. So ports are basically, we can think of them as how our domain imagines the outside world to be, right? So it imagines it can be consumed in some way, and also it imagines that it can consume the outside world in some way, but they are there to shield it from any dependencies, right? So it's strongly isolated from the outside world, concerns, and we have the adapters doing all the heavy lifting. And basically, this is all that you need, right? So we can do a very quick hello world, write some quick application, and you can go save the world with hexagonal architecture. But is that true, actually? Is it enough to understand what's going on in here? I would wager no, because this model, as much as it is very useful, obviously, and I hope correct, I didn't make any mistakes, it's also, I would say, behavioristic. So it focuses on hows and what's, but it doesn't really focus on whys. And this is what I would like to focus on today. So my name is Krzysztof Przygudzki. I'm a software developer. I currently work for Hyperexponential. I used to work for Hazelcast, for Toke. I used to be a team leader for a team working for Allegro Smart, something like that. You can also find me on Twitter, or X, as it's nowadays called. You can find it here. And the most important slide, right? So I encourage you all to, you know, try this at home or at work. It will be great, but remember, you do it at your own, not peril, but responsibility, right? So I take no responsibility for anything that comes out of it. And now that I've established some sense of authority and some trust, then we can proceed to the rest of the presentation, right? So hexagonal architecture, we said that it isolates strongly the domain from the outside world concerns. But what does it mean, really, to isolate stuff? So instead of looking for some encyclopedic definitions, I would rather, you know, work on some real-life examples, and something that all of you probably do on a daily basis, you know, some very, very simple stuff on the very low level is we extract functions, right? So we break our code, bigger piece of code, into smaller pieces. We call them functions. This way we decompose a more complex, larger problem into a number of smaller problems which are easier to understand. And we also introduce abstractions with these functions. The functions also promote code reuse, right? So instead of duplicating some code across our code base, we can just call the same function from different places, right? And hopefully, when later we need to change some implementation details, we only need to do it in one place and not many places. So we have, this way, we have also collocated the changes that need to happen and hopefully increase the cohesion a bit. At the level up, we can also talk about extracting classes. So in Java and JVM languages specifically, Java is strongly OOP, so we can focus on the objects. Special kinds of classes, they're ones that they collocate state and logic that operates on that state, right? So it's related to that state, and these things also happen to change together often, right? So when one thing changes, probably the other changes as well, and they not only collocate, but they also encapsulate state, right? So instead of exposing state, they expose behaviors, and these behaviors form a sort of an API of an object. So if you want to change a state, you don't do it directly, but rather call some behaviors that change the internal state, and also they guarantee that the internal cohesion and correctness of this state. They also reduce coupling, right? Through this API. Technically, we can change the internal state, or like model of the internal state, and as long as we don't need to break any APIs, we can do it just, limit the scope of changes to just the internals of the object. We don't have to change the code that consumes this object. And lastly, also objects give us some sort of abstraction, right? So it's, I think, a common metaphor, common way to think about OOP. It's like we go, when we work on some object, we go into a box, and when we're in that box, we don't really care what's around, outside of this box, right? So only care what's inside, and probably what we see inside is just more smaller boxes. And we don't really care about what's in the internals of these boxes, because only we care about the APIs of these objects, right, that we're consuming inside. So it's all boxes all the way down in the OOP, and this also helps us reduce cognitive load, right? So it's easier to reason in scope of a single object rather than in scope of huge application. And going yet a layer up, we can break our code down into packages, right? So as our application grows larger and larger, we need to somehow manage this complexity and this size. And what we can do is we can divide our application, so extract some packages, right? And there are two ways of dividing or like extracting the packages or dividing, slicing the application. And first one is vertical slicing. And I mean, obviously, there's nothing vertical inherently about it, it's just a metaphor, right? So the metaphor is that when we slice vertically, we just slice based on the domain context, right? So for example, we have some classes related to products, and we put it in one package and label it products, and then we have some other code that's related to invoices, we put it in another package and we call it invoices, and there's order in a word now, right? So if you're looking for, we're looking to change some code, or you just want to read it, some code related to products, you go to the products package, because that's probably where it is, and it makes your life easier this way, right? It also has this added benefit of co-locating changes, right? So it's easy to imagine a change that will hopefully only touch the classes that are related to products, right? We need to change some internals of the products. So hopefully we'll only change the internals of this one package this way, right? So these changes are co-located. It's easier to locate things that need to change together. But also maybe I'm changing 5 classes and there's like 8 classes in total in this package. So maybe this just prompts me to check the other classes. Maybe they need changing too. Yeah, so it kind of helps us prevent any sort of issues, right? So the alternative to vertical is horizontal, obviously, right? So again, this is a metaphor, and this is a metaphor for slicing along more like technical context boundaries. So we can say that we have some classes that are related to databases, so we can call them, we can put them in a package and call it persistence, for example, right? Then we have some classes that are related to exposing REST APIs, so we can throw it in another package and call it presentation, for example, right? So again, this introduces some sort of order into our world. When I want to change or read something that's related to REST APIs, I'll just go to the presentation package, right? And everything will be clear. And based on that, so I guess we, down the line, years ago, we decided this is more useful more useful approach to slicing our applications. And that's how layered architecture came to be. But it also introduces one important concept and one important rule. So first of all, with layered architecture, these are no longer just like abstract horizontal things. We now introduce an axis and place those horizontal pieces along those axes, so one is on the top, one is on the bottom. And then we can think about those as layers. I think it's a useful visual to assist us. We also introduce one important rule and say that the layers on the top can depend on the layer underneath them, but not the other way around, right? So we have the direction of dependency from top to bottom. So in this example, this is the classic layered architecture. So we have the presentation layer on the very top, so it can depend on all the layers beneath. We have the business logic layer in the middle, so it can depend on the persistence layer, but it cannot depend on presentation layer. And then we have the persistence layer at the very bottom, and it cannot depend on anything, really. And this is classic in a like worst, outdated sort of way, and I'll get to why in a very, very quick moment. And the question again is it useful? Does it help us in any way, right? So I guess you can find some usefulness in that, because with having this presentation layer on the very top, you can technically nothing else depends on it. I mean, this guarantees that nothing else depends on it. So if you want to expose some new API, you have been working with SOAP and you want to work with REST now. Well, technically speaking, it should be a limited change. Only need to change the presentation layer and you'll be good, right? On the other hand, you have the persistence layer on the bottom, so everything depends on it. So changing something in that layer might involve changes. There's no guarantees. It can involve changes, or it can introduce or make you change the other layers as well. But maybe it's useful because we want to add some new column to your database table. Then probably you also need to add it to the JPA entity. You also want probably expose it in some as a JSON attribute or something like that, right? So it figures you probably want to do it either way. So that's cool. And that's not really true, because this drives us away that we call database-centric architectures, because we have the database at the very core of our application, and effectively everything depends on this database thing inside, right? So we start, and also pushes us or drives us to think about the application based on this very internal layer first, right? So whenever we need to do some change, we first think, oh, what do I need to change in the database? And this is, I think, not the way we should think about our applications, right? Because this is not the database representation, it's not the database model, it's not the most important thing about our applications. So everything depends on the persistence layer. Whenever we want to change something in that layer, everything else might be impacted as well. And also, there's this thing called anemic domain models, and you might ask, like, how is it involved here? And the answer is simple. So we start with this persistence layer. I would have the database tables. Based on that, we written or maybe auto-generated some like JPA entities or some persistence model to go with that database model. And then we, initially this is super easy because we are maybe working on some CRUDs. So, well, it's cool. I just need this one model. I can do everything with it. Maybe I have a separate model for the responses for like JSONs, but maybe not. Or maybe I need to do the mapping. Maybe I can use some library to do the mapping for me. Maybe it's not really important. But then, as our applications grow, we add some more domain logic, maybe some more interesting domain logic to that. So we have growing business logic, and this business logic needs to live somewhere, right? So ideally, we would create some objects that would be not just state, but also they would have behavior, right? So they would hide this state. But we have all this persistence model already, right? So there's where our state lives. So we either have to add this business logic to the persistence model, but persistence model lives in the persistence layer, and business logic, I mean, it's kind of obvious where it should live, right? It should live in a business logic layer. So we don't want to add it to this persistence layer entities, because it's wrong. So what else can we do? I guess we could duplicate this model, right? So have a separate domain model and map between the two every time, right? So I get something from the database, I get the persistence model, so I have to map to my domain model. So there's a lot of extra work, and I don't want to do it, right? I'm not about doing extra work because it doesn't really pay anything. So what I end up doing is I end up smearing all that domain logic on business logic across services, and we end up with smart services and dumb entities, and this is precisely the anemic domain model that we would like to avoid. And the issue with that is, is that additionally, the other issue is that the complexity in our applications as they grow complex, right? Because if you are working with CRUDs, that doesn't really matter, all these things, right? And you have other concerns to think about, not the vertical aspects of how to slice it, right? But when your application grows, it accrues and accumulates more and more business logic. The complexity is that within that business logic layer, and first of all, you don't want things like anemic domain models, but also you want to limit things that can potentially cause changes to this business logic, right, layer, because you want that code to be isolated. You don't want it to change because of some external factors, right? You also want to limit the like Git history, Git log of your changes to that layer. So basically, what effectively we would like to do is we would like to get rid of that persistence layer, at least get it from underneath the business logic layer, so that the business logic layer would live at the very bottom. And where there's will, there's way, and we can do that very thing using something that we call dependency inversion pattern. So the pattern itself is pretty simple, right? So I mean the goal, what we are trying to solve basically is we want to change the direction of dependency between two components. In this particular example, it's the layers in our application, and without changing the direction of control, right? So I still want my business logic layer to be able to call this persistence layer. It just don't want to know about its internals. It doesn't want to know how it works internally. So the way to do it is with this dependency inversion pattern. Basically, what we need to do is the business logic needs to expose some interface and declare some use cases within that interface, and then the persistence layer, which depends on this business logic, so it sees all those interfaces, all those methods. It just needs to implement those interfaces, those use cases, right? By consuming some external systems like database or external service through HTTP clients, etc., right? So, and also, yeah, we have the HTTP clients, we have all the other stuff. So we want to maybe publish some messages, etc. So these all fit the same pattern, basically, right? So we want our business logic to be able to use that code, but it doesn't want to know about the specifics, right? So we can basically stop calling this layer persistence layer and just use something more generic so that all these other elements fit in as well, right? So we put all those technical stuff that our domain, our business logic layer needs to use, and we put that in the infrastructure layer on the very top. And this is how we arrive at the modern layered architecture. And the modern layered architecture from top to bottom is infrastructure, presentation, and business logic layers. And so infrastructure is on the very top, so it sees and can consume and depend on everything below. Then we have presentation layer, which only depends on the business logic layer. And then we have business logic layer, which depends on nothing. So it is perfectly isolated from the outside world. So I don't know if you're triggered, but 20 minutes have gone by and I have made a big circle, basically. And as we started this presentation, we said that the hexagonal architecture is something that promises us that it will isolate our domain ideally perfectly from all these outside world concerns, right? So it was supposed to solve this problem, but I have now just solved this problem in the layered architecture, right? So why do I need hexagonal architecture at all? And there are a few things that I would like to show you how it can be useful, how it can be helpful to us, which might not be that obvious at the beginning, but bear with me. So we have been talking a lot about the direction of dependency, right? So layered architecture, the direction of dependency is top to bottom, but then there's also this thing called direction of control, right? So my infrastructure layer calls the presentation layer, etc., etc. So how these do things, how do these layers play together in that aspect. So let's analyze this on a very simple example. We have some incoming HTTP request to our web service. And so first, this request will land in a controller, which lives in the presentation layer. And this controller will call some service, which lives in the business logic layer. And then this service perhaps needs to retrieve something from the database through the repository. So what it does, it calls this, this database logic, database interoperation logic, which lives in the infrastructure layer, right? So basically, it like stretches its hands from the very bottom to the very top. So as much as the direction of dependency is clear and it's top to bottom here, the direction of control is actually inconsistent, right? Because sometimes it goes to the top, sometimes it goes to the bottom. Is it a problem? I don't know, we'll see in a moment. And the other question is, how does hexagonal architecture solve this problem? And it's with a very simple trick. And this trick is that we go from 1D graphics to 2D graphics. Yay! And so basically, we just introduce another dimension into our graph, or into our diagram, and then we can model much more things, as it turns out, based on that. So let's analyze the same example. So we have this request. It comes into the controller. The controller lives in the primary adapter to the left of this diagram. Then it calls some service. So this is the primary port, again on the left side of the diagram. And then the service calls the repository, which is the secondary port to the right. And then this repository is implemented by the database adapter, something, again, secondary adapter on the right side. So as much as we have the dependency going from the outside in, we also have, so it's consistent and clear, we also have the direction of control going from the left to the right consistently without any complexity, right? So you didn't know you have this problem, but hexagonal architecture comes in to the rescue to solve you from it. Great. What else? We have also another aspect could be project structure, right? So to the left, you're probably all well familiar with this sort of like project structure. So we have our application, domain, infrastructure, and presentation packages, right? So this is like a classical structure of like a layered architecture project, software project, right? And to the right, we have the equivalent, but like it's structured based on like hexagonal architecture approach. So the question now is how these packages to the left map to the to the packages in the project to the right. And so obviously we have application and domain, and they just map to the application domain. I mean, there's nothing complex about it, right? I mean, it's obvious. But then we have infrastructure and presentation packages, and there's no infrastructure and presentation packages to the right. So how does it map? And the question is, the answer is obviously, let's start with infrastructure. So infrastructure, what's in our infrastructure package? So we said that, for example, we have the database implementation, right? So maybe some JPA code or JDBC or whatever. So all of that would live probably in the adapters JPA or adapters JDBC, right? So in this example, we have just put all the adapters in one package. You can split it into primary and secondary adapters. It doesn't really make all that much of a difference, I think. Yeah, so it's just adapters JPA. It's clear, right? But not really, because there's one issue with the infrastructure layer and the infrastructure package, and the issue is in the name. The name is very vague and broad and generic, so we can technically cram everything in there easily, right? So, so for example, we can cram some configuration. I think it's a common pattern that people put configuration code in the infrastructure layer. Is it good to put it there? The answer is obviously, it depends. So if we have the adapters JPA package, for example, so the JPA adapter, maybe some configuration related to how we store dates in the database, for example, maybe it makes sense to put it there. But things like, for example, configuring Spring or configuring, setting up some beans together, etc., it probably shouldn't live in the adapters package, right? And so maybe we shouldn't put it in the infrastructure layer. And then the same thing is with, or also the other question is about presentation layer. So how does it map to the hexagonal architecture project? So what are examples for presentation? So presentation layer could contain something like REST API controller or something like that. So it should probably go to adapters REST, right? So it's pretty clear. But there's a different kind of issue here, because it's not about whether things from this package should all go to another package or maybe some other packages, or should they belong there in the first place. It's a different way, because what about things like, for example, message consumers, right? Or task schedulers, at least the parts not where you schedule task, but when you already have scheduled task and it's time to do something and it needs to call your code, right? So where do you put those? And should we go to the domain? Probably not. Should we go to the application? Maybe. Should we go to the infrastructure? Maybe. But let's see how hexagonal architecture answers this problem or this question. And so first of all, is it part of the domain? Is modeling message consumers part of our core domain? Probably not, right? So it should probably go to some adapter. And then the question is secondary or primary adapters. And the question then is, does it consume our domain or is it consumed by our domain, right? That's the difference between primary and secondary adapters. So with message consumers or task schedulers, again, the part that consumes some tasks and calls our code, obviously it consumes our domain, right? So it should go to the left. It should be a primary adapter. And based on that, we can say that this code should probably live in the presentation layer. I don't know if this is the answer that you have always arrived on, or is it something new to you, but this sort of stuff should go into presentation layer. Then the big question is, what if our application grows too large? How do we tackle that? And how does hexagonal architecture help us with that, right? So we have this horizontal division based on our layered architecture, right? And so how could we solve this problem of having too many classes? These layers grow too big, right? So first of all, we can try and introduce more layers. Great. We can split our business logic layer into domain and application layers. And that's useful and probably works. But as we try to add more and more layers, we find that it doesn't really work. Why? Because it's kind of hard to introduce more layers than that and still stick to this rule that the dependency should only go top to bottom, right? I mean, we can introduce some layers, but they don't really play along with this approach very well. So it turns out that maybe, I mean, it obviously depends on the case and may differ case by case basis, but it turns out that 3 or 4 is actually a very good number for a number of layers you should have in your application. So what can we do instead? So we can introduce some, we can divide our code horizontally, so introduce some abstract horizontal stuff within our layers, but not follow, no longer follow this rule, right, of top to bottom direction of dependency. So what we can end up is we have a separate package for services, separate package for controllers, separate package for exceptions, separate package for DTOs, separate package for requests like representations, and a separate package for response representations, right? So our JSONs. And is that, again, the question that we asked before and we should ask again, is that useful? Does it help us? So technically speaking, when I'm trying to navigate the code, it's great because I know, am I looking for a message consumer? Or am I looking for service, right? So I can easily navigate this project. But then we also mentioned that this is like a good litmus test of whether the approach is good or not, is to check, does it collocate the changes, right? And in this example, it's really, really easy to find situations like I'm doing some change. I'm probably going to touch like one class from each of those packages, right? Because I need to change one service, I need to change one DTO, I need to change one entity, one controller. So basically, instead of collocating the changes, it spreads them all over the place, right? So not really good for cohesion or collocating changes. So the approach is, so the alternative that we discussed before, we have horizontal, we have vertical. So what if we, within our horizontal layers, we just slice the code into more vertical packages, right? So we said that we have some products, we have some invoices, maybe some orders in between, etc. So let's, within each of these layers, slice the code into packages like that. And this is a bit idealized situation because most often the application and the domain layer are the ones that grow the most. So these are, where we apply this, and maybe the infrastructure and presentation just still are a single package. So we don't really have this like consistency in the number of layers. We don't have this like, vertical slices, but it's more often more complicated than that, right? So again, is this sort of approach useful? Does it help us? And in terms of like collocating these changes, it is useful because you can imagine a situation where you're doing some changes, and you need to change some classes, right? And maybe they're not located in one package, literally, but maybe they're just located in this single virtual slice. So maybe it's not that great, but it's pretty good still, in collocating the changes, right? So we collocate the changes. It reflects our like context or like vertical slices in our application pretty well. But then there's the other question about coupling, right? So how does it help us solve? We don't want to end up with like a spaghetti monolith. So how do we approach this? And let's analyze. So we have a pretty simple example, right? Use case that we want to implement. So we have the our invoice service. When we want to issue an invoice, we need to get some data from the product and put it on the invoice, right? So what do? We can just go to our invoice service, inject the product repository in there, retrieve this product, get the information we need, and save it to the invoice, right? Or actually, why go through all that trouble when I have the JPA model and I can just push it all there? I can push it all to the database. So I can introduce the association between some JPA entities. So I can introduce, my invoices will now have like a list or something, a collection of products, right? And it's all great. Life is good. I don't even need to inject some beans, right? Some repositories. But then we can also imagine some other examples, some other use cases that one. So the product manager comes to us and says, oh, I also want to, we have these products right now, and this is like more like product versions, and you can edit these versions, like, an admin or something, a owner of the shop can change those products. But it should be that they no longer can change those products once this product has been sold, right? So once we have an invoice for it, we shouldn't be able to edit it anymore. So then in this example, in this case, we'll have to just create a new version of the same product and go from there. So they can edit the new version, but the old version needs to stay there. So how do we solve this? We have our product service. This needs to check this invariant. So just let's inject the invoice repository into there, and let's check, are there any invoices using our product? But the issue, or again, we can also push it down to the base model. So we can again push it down to our JPA model or our database actually, and we can just introduce a foreign key or an association, whatever, so that we don't even have to inject these beans, right? And by doing all this stuff, we are actually introducing logical dependencies from one of those slices, vertical slices, to another, right? So from one context to another, and by doing this, in different directions, what we have done actually is we have introduced cyclic dependencies, right? or bidirectional dependencies. And maybe we haven't even noticed that this is a problem until now, right? But if we are going to want to split this code, this application, using these vertical slices, using context into more applications down the line, for example, go to microservices, right? Or just have like a modularized monolith at the moment, we can't really, we don't, because these are tightly coupled together, right? So they need each other to do their work. So we said that horizontal, so we have arrived in this like spaghetti monolith, and we said that horizontal division is not really good. Vertical division is not better, not much better. So what's the alternative, right? We said that these are two alternatives, two options. So what else can we do? So the the issue is that we have kind of, by sticking to this horizontal architecture, the layered architecture, we have kind of locked ourselves, like we're painted ourselves into a corner and decided we want to go horizontal first, right? So first break down this application into layers, only then think about what should happen next. And the alternative is actually to go a step back and start by dividing this application into vertical slices. So we can divide our applications into modules. So use the vertical first approach, slice it into modules, and then only apply the layered architecture, whatever other application architecture that we want later on, right? Within the boundaries of those modules. So then we have this, again, this invoice repository service consuming this invoice repository. So we don't want that. How did it really help us solve this issue? Not really, not on its own, but let's go a step further and let's say that our modules now have APIs. So you can't just, inject any sort of class willy-nilly. What you have to do is actually you have to, if you are, invoice service that needs information about the product, please go speak to our product service or product facade or something like this. So, use the entry point, our API, to our module and not use the internals, right? Furthermore, we can also say that our modules should have SPIs, right? So right now, my invoice service would like to inject the product service maybe or something like that. But what if I want to break the, split product service into multiple services, right? Or want to change something, or maybe I want to introduce read models or whatever. Plenty of ways I might want to change it, and then I probably don't want all these changes within the product module to impact the code outside of those modules, right? So instead of what we can do is our product module can have again in our domain layer we can have an interface and say let's call it product client, for example, and then it can be implemented by the infrastructure layer, and then only infrastructure layer will be impacted, right? If I want to do any changes to the product module, maybe split it into two modules, then only this one class, this adapter, will be impacted. And this doesn't necessarily, solves the issue in a sense that it guarantees that the issue is solved now. But what it does, it just brings those issues to the forefront and helps us notice them. It just underlines those and makes them more visible to us. So in some instances, probably it can actually solve it because if we are using different packages or actually just with like Spring Beans, we might end up at situations we have cyclic dependencies between beans, and then instead of using lazy loading, let's just think, did we arrive at this problem in the first place, right? And let's try to solve it. And also we can see that this approach plays very well with our hexagonal diagrams, right? So hexagonal approach. So we have some service within the invoice layer, invoice module that calls the product client, which is the driving adapter on the left, and then we have this like bridging adapter, and it calls the service, which is the primary port, the driving port of the product and product module, and then there's some internal logic happening inside the product module, right? So the point I'm trying to make here is that perhaps the hexagonal architecture is not just an architecture of a hexagon, but rather it's architecture of many hexagons, right? And it can help us with breaking this, the monolith into more modules and do it cleanly. So there's also, let's maybe take a closer look at the adapters and how they work. So I have mentioned before that our domain, let's just focus on the adapter on its own first. So we have the adapter design pattern. And basically what it does is we have two components. These are active component and passive component. One consumes the other, but we don't want any dependencies between them, right? So it's like our application needs Spring, but it doesn't want to know about Spring. So we call guys from Pivotal, but they say, no, they don't actually want to know about application either, right? So we have to somehow figure a way where neither party knows about each other, right? So the way to do it is with the adapter pattern, right? So the active component, again, introduces or exposes an interface that declares some some use cases, how it's going to use the other component. Then there's the adapter that implements this use cases, implements this interface, and implements those use cases by consuming the passive component, right? So this way, there's no direct dependency between those two pieces, between those two components, but one can use the other. And with regards to our hexagonal architecture, this is how those play together, right? So we have the primary adapters. So we have this external component, which technically should expose some interface, and we should implement this interface, and this adapter should then call our service or our domain or something. But actually, if you're working with Spring, this is not how it works, because with Spring, we want the declarative approach, right? So instead of implementing some interfaces, that's dumb and for silly thing to do. So instead, let's have some annotations. Yeah, and if something doesn't work, let's just sprinkle more annotations. So this is an example of our product controller. So it is a driving adapter. It consumes a driving port, which is the product service. Yeah, and basically that's nothing more than that. Because all of this stuff with with interfaces, implementing, etc., we don't really do it, right? So we just write some code and add an annotation, and you can think about it in such a way that there is actually some interface behind the scenes, and there is some implementation for that interface, but it's auto-generated by Spring based on those annotations. And on the other side of our hexagon, we have the secondary adapter. So our domain wants to consume some external component. So what it does, it exposes some interface, so like a repository, for example. And then we have a driven adapter. So it implements this interface. So it may be like a Spring GPA or something, Spring Data GPA repository, which actually consumes the external component, right? So some Spring interfaces. So this is the example. And so we have the Spring Data GPA product repository, and it implements our driven port, so product repository. So it's part of the domain, and this is the adapter. And then it consumes this internal product repository interface. So again, this external component can expose a class, can expose an interface. It really doesn't matter in this example, right? But the things to maybe notice here is that we have this internal product repository at the very bottom of this slide, where we might often be tempted not to do it, right? Like, what's the point? Because I already exposed the product repository interface. So this is like my domain interface. But then why should my domain could just expose this internal product repository interface directly, right? And have it extend the CRUD repository, whatever other Spring repositories, Spring Data repositories, and it should be fine. And that's not really the case, and I would try to dissuade you from it, because first of all, this is the thing that allows us to do this sort of like decoupling, or not decoupling, but separate the domain model from the persistence model. This particular class is what helps us do it, right? Because we have this mapping, this context mapping in there, and this is doing the heavy lifting to bridge between those two worlds. And also, if our interface in our domain extends some interface from Spring, I mean, this is obviously it's just some pollution that we bring, and there might be some leaking abstractions in there because of that. And just as a bonus, we have like the intermodular adapter, right? So we have two modules. One module wants to consume the other. So the thing that I want to convey here is that we don't really need two adapters, right? Because you might think, oh, I have the driven port, I have the driving port. I should have two adapters, so driven adapter and driving adapter. But actually, we only just need one. So like a bridge between two models, we need one class for that. So then we have this. We said, we mentioned the dependency inversion principle before, and the pattern. But there's a difference between the pattern and the principle, right? And the clue of the principle is that. So here's the definition, basically. So communication between components should happen on the highest mutual level of abstraction, and component of the higher level of abstraction should never depend on the implementation details on the component of the lower level of abstraction. So what does it mean really is that, for example, as we as our application is consuming, some database, for example, right? We want to use our database to store some data. The adapters, ports and adapters are there so that we prevent any sort of leaking from the outside world into our domain, right? So all the design, technically speaking, should go from the inside out. We should start with designing our domain. We should decide how this domain wants to consume some database, for example, without particularly focusing on what sort of database that is, right? So just focus on the domain-driven use cases, and then have the adapters do the heavy lifting, do this, do this context mapping. And that's important because if we do it this way, if we do it properly, we don't have, this leaky abstractions. Then we can easily interchange those adapters, right? So simple, the one example that's I think pretty common and people like to refer to it is like, oh, I want to change my SQL database into non-SQL database or something like this, right? This is, and the common counter argument is that no one ever does this, right? I've never done it, so I'm not going to refer to that. Same goes with changing Spring for no Spring or something like that. I mean, these things should be possible if you've done things well, right? But you don't have to go into that much involved examples, right? This can be useful with very simple cases where you just want to swap your adapter for tests, right? So you want to have a test double that you want to, like a fake, or maybe you just want to mock some stuff. So this boundary of the hexagon is a great boundary to have for your unit tests, right? So you can write tests that encompasses all the internals of the hexagon, and you can mock the secondary adapters, secondary ports, and then you can just have your tests call the primary ports of your application to trigger it. And then it should be easy. Also, you can have a bit more involved use cases, like, for example, let's say your application now consumes some configuration details from like just files in the resources, right, of your application. But what if you need some more involved stuff? Maybe you need to change it through the database, for example. I mean, you want to changing regardless, or you want to change it in a way that is decoupled from the lifetime of the service itself, right? You don't want to deploy, for example, to make some changes. So one way to do it is to have it stored in a database, right? So we can do an update and put some stuff in the database just to replace, just to change things. And maybe then you also want to expose some APIs to allow for changing of this configuration. And the point here is that if you have, in the first place, thought of this configuration as some outside world concern and hidden it behind the port and hid it in an adapter, all of this implementation, you can now technically swap these adapters and go from just reading static file or just using Spring properties or something to using a database, reading it from the database every time you need it, and go to like a full-fledged side module that you might later on just lift out of your application into a separate application to have microservices architecture. And as long as you have designed your interface well, your port well, technically speaking, you never need to change, introduce any changes to the insides of your domain, of your primary domain. Everything, all of these changes will be encapsulated on the outside. Yeah, so that's all beautiful, right? And we can tell beautiful stories about how we can, prevent leaking abstractions, etc., and keep everything clean. But we can't always do it clean, right? So one example of that is with transactions. If you're modeling transactions in your application, initially it might be pretty simple because, well, I have this like add transactional annotation. I want to do it, use it somewhere in our code. So where should I put it, right? Domain, not really. It's not part of my domain. Application layer, maybe, but not really. So maybe I should just put it in the driven adapter, so secondary adapter that's related to the database, right? So let's put it there. And that's cool as long as you open one transaction to take some data, read some data from the database, and then transaction is closed. You do some stuff, then you open another transaction to save this data, right? If you're working with SQL databases, that's crucial, right? Because if you want to change multiple entities at the same time with the save operation, especially if you're working with aggregates, that's crucial to have, right? But then maybe as your application grows, it's actually needs some more involved stuff, right? Maybe you need some locking, and maybe with optimistic locking you can still get away with it. But if you want pessimistic locking, for example, then you have to guarantee that the transaction will be open between the whole unit of work and will be closed only after this whole unit of work is finished. You can't have two separate transactions because this locking will not work at all. So as you know, at some point you come to the conclusion that you actually your application logic depends on some transactions or some locking mechanisms. And if that's the case, maybe you actually need to implement it in your application, right? We can't just always have this perfect, ideal, clear models and just use them. We're not writing in Haskell. We actually need to make our applications need to make some money. So our code is actually just implementation of some business use cases, right? And that's also something to keep in mind. So to close out, I know it's a bit late, so I'll be fast. So the question I'd like all of you to leave here with is, what is architecture really? And is it all of these package structures and all these design patterns that we're using, etc.? And I would say no, because I think abstraction is more like some mental model that we have. It lives in like the ideal world, and the code that we write is just like an imperfect reflection of this ideal world, right? But the point is that the code that we write is also a tool for us that we can express ourselves. We can express this mental model that we have, and the point is that we should strive for this code and our expression to drive everyone to think. To have the same mental model, right? So once I read the code, once I read your code, I should be able to think about it the same way that you do, right? So there should be the least number of inconsistencies and mistakes possible. So this is also important to think about this crucial expression tool. Yeah, I'll leave it there. Thank you very much for your attention.